Hey guys, let's do some more of these examples for this percent hydrate assignment. So I do know it's a little bit tricky, that's why it's worth a little bit more. But just a reminder, there are some really good tips in this purple part of this assignment. So remember, when we are starting our calculations, we are rounding the mass of the elements to the nearest whole number. And then we have to make sure that we are rounding our answers to the correct number of sig figs. And that's probably where some of us are running into some issues. If you need to review sig figs, it would be in your intro unit. Your modules are still open. You should be able to access that. But of course, if you have any questions or you have a few specific questions you just can't figure out, if you just shoot me a message, I can help you. Okay. Also, make sure you are including a space in between your units. So I've had a couple of issues with that where students are just putting like a G right after the number, but you have to have a space in between it for it to calculate it correctly. Okay. All right, so let's go ahead and take a look at number 5. So what is the molar mass of CaCl times 10H2O? So this is a hydrate. 10 is dec, so this would be a calcium chloride decahydrate. Okay, so first thing we're going to do, we're calculating the molar mass. We are just going to add up the average atomic masses of each of these. So I'm going to start with calcium. I'm going to do my work here. So calcium is, let's find calcium. Calcium is 40.078. We're going to round that to 40 grams. Next up we have chlorine. So chlorine is 35.45. We'll round that to 35. And that is going to be 70 because there's two chlorine, because it's CaCl2. There's two of them. We have to include that. Okay. And then of course there is water. And water is always 18 because hydrogen is 1 and there's 2 hydrogen. So 1 plus 1 is 2. And then oxygen is always 16. So 16 plus 2 is 18. So water is 18. And then there's 10. So that's going to be 180 grams of water. Okay. But we have to add them all up. So total molar mass is going to be 180 plus 70 plus 40. Okay, so 180 plus 70 plus 40, and that gives me 290. So I will have 290 grams per mole. Okay, now remember, when you're adding, you report to the least number of decimal places in the problem. Okay, so these are all whole numbers, so there are no decimal places. So the least number of decimal places is 0. However, this particular problem ends in a 0. Okay, remember, trailing zeros are not significant unless we add a decimal point. So in order to make sure this is significant, we have to add a decimal point right here because that tells us that 0 is significant. Those are the number of sig figs that we have. Okay, so for 5, we're going to type in 290 decimal point grams per mole. Okay, and it has to be written exactly like this, grams per mole. Okay, and that's correct. It'll pop up. It was a little bit slow there. Okay, so this is number 5 could have been tricky because it needs the decimal point. On that first document that we did, I did include the numbers that would be like that. So if you need me to send you the link to that, just let me know. Okay. All right, so number 6 says, what is the total number of grams of water in 1 mole of calcium chloride decahydrate? Now, this at first glance might seem a little bit tricky, but all this is asking for is that in that last molar mass that we calculated, how many grams of that was water? So if we just go back to our calculation here, we had 290 grams total, but our water was 180 grams, okay? And it's going to be the same thing with this. So that 0 here is going to be significant, so we're just going to go ahead and add that decimal point there. So I'm going to do 180 grams, and that one is just in grams. So when it's asking for the grams, you just have to put grams. And as a reminder, the way that we're doing these is the same process for all of them. Okay, so there are 4 molecules here. So yesterday we did calcium sulfate hexahydrate, and then in class together in teams if you missed that. And so the first 4 were for that one molecule. Okay, so there's 20 problems, but there's only 4 molecules, and the process for each is the same. Okay, so like the process for 5 through 8 is the same as the process for 1 through 4. The process for 9 through 11 is going to be the same as what I'm doing right here. So if you can have the examples for, 4 of them, the process for completing them is the same. Okay. All right, 7% mass of water and calcium chloride decahydrate. We are going to come over here, and percent mass of water is just the same as like doing any other percent composition. It's just that we're looking at the percentage of water instead of the percentage of a specific element. So I'm going to insert an equation. And remember, percent hydrate is just the grams of the water on top divided by the total grams of the molar mass times 100%. So we had 180 grams of water, and we had 290 grams total in our molecule. Okay, and we have to multiply that by 100% to give us our percentage. I'm going to make this a little bit bigger. So it'll be 180 divided by 290. 180 divided by 290 times 100%. Oop. Nope. Oh, no. Sorry. 180 divided by 290 is going to give us 0.6206. But of course, if we multiply that 100, that'll be to 62%. Now, we do have to, because this is a division problem, we report to the least number of sig figs, right? So in this case, the 180 and the 290 that we calculated here, those were both significant, right? Because we had the decimal places behind each of these. So there are 3 sig figs here. The least number of sig figs is 3. So it's going to be 62.1%. So it should be 62.1%. Okay. So 62.1%. Perfect. All right. And then finally, what would be the mass loss due to heating of 15.45 grams of that calcium chloride decahydrate? So if you think about heating a substance, water, when it's heated, it evaporates, right? So what this is asking us is if we have this amount of this molecule, if it's heated and the water is lost, how much is going to be lost in grams, okay? So it sounds kind of complicated, but really it's just asking like what percentage of this particular amount of this molecule is going to be lost. So to do this, we are going to take the amount that's given to us. It's going to be 15.45 grams, okay? So it's 15.45 grams, and we are going to multiply that by the decimal form of our percentage of the water that we calculated, because that's how much of the water would be there, and that's how much would evaporate, okay? So 0.621, okay? And then if we put that into our calculator, so 15.45 times 0.621. And this is just percentage math. Anytime you want to find the percent of something, you multiply it by the percentage in its decimal form. And that gives me 9.59445. Okay, so it's 9.59445. Okay, now here's the thing. We have to round to the least number of sig figs. There's 4 sig figs here, because remember, any non-zero number is significant. Here, there are only 3 sig figs, right? Because the leading zeros are not significant. So there's 3. So we need to report this to 3. So this is going to be 9.59 grams. Okay, so let's go back in and put 9.59 grams. And that is correct, okay? So these are just another set of examples. Like I said, the other problems on here are the same pattern, okay? So you're going to be starting with when it gives you a new molecule. So like in number 9, it's going to give you a new molecule, and it's going to ask you the same 4 questions per molecule. So you calculate each of these the same way. For the molar mass and the number of grams, remember, if it doesn't end in a 0, you don't have to put the decimal place, okay? So really, I think for these calculations and for this particular assignment, the tricky part is just remembering those sig figs and remembering how to calculate them. So remember, if you're adding, it's the least number of decimal places. If you're multiplying or dividing, it is the least number of sig figs, okay? Not every single one is going to need a decimal place. It's only if it's got a 0 and that 0 is supposed to be significant, okay? All right, so I hope this helps. If not, remember, you guys can always come to office hours and we can do some more together.